Now we're going to try and find out how much energy is needed to raise the temperature from 23 Celsius to 50 degrees Celsius. So at the moment the water level is at the moment the temperature of the water is 23 degrees Celsius. The water level here is from 0 to, let's say, 4 centimeters. Okay, so currently it's 23 degrees Celsius. How much energy would be needed to raise it from 23 to 50 degrees Celsius? Okay, so now we're going to develop a way of working that out. So one calorie is defined as the amount of energy needed to raise. Let's say this is 1 centimeter here. This here is 1 centimeter, and the depth here is 1 centimeter. So one calorie is the amount of energy needed to raise 1 by 1 by 1 centimeters cubed of water by 1 degree Celsius. Okay, so 1 calorie is defined as the amount of energy needed to raise 1 milliliter of water by 1 degree. Okay, so if this were, let's say, mercury, then the amount of calorie needed would be different from water. It has to be water. It cannot be anything else. It cannot be alcohol. It cannot be mercury. It has to be water. So 1 calorie is the energy needed to raise this by 1 degree Celsius. Okay, so suppose you have a beaker. Let's say you have a beaker that is 4 milliliters. Okay, if you inject one calorie into this beaker of water here, if you inject 1 calorie into here, then one of the cubes will be at 1 degree. So let's say at the moment this beaker here is at 0 degree Celsius. Okay, if you inject one calorie into here, then you're going to raise one of the cubes by one degree. If you inject another calorie into here, then you have a choice. This will increase to 2, or this will increase by 1. Okay, so now if you inject another calorie into here, then maybe this will go up by 1, or it could be this. This will increase to 2. Now you've got 2 and a 1. If you inject another calorie into here, then this will be a 2. If you inject another one, then this could be a 3, or this could be a 1 degree Celsius. If you inject another one in here, this could be a 3, or this would increase by 1. If you inject another calorie into here, then this could be a 3, or this could increase by 2, and so on. So 1 calorie is the energy needed to raise to raise 1 milliliter of water by 1 degree. Okay, so hang on. So let's just look at this scenario here, where it's currently it's at room temperature. Say let's just imagine that let's just imagine it is currently at 0 degrees. If you inject this many calories into 4 milliliters, then you're going to bring it to 23 degrees Celsius. So basically, if you inject this many calories in here, then this will be at 23. This will be at 23 degrees Celsius, 23 degrees Celsius, 23 degrees Celsius, and so on. What we want to know is the amount of energy needed to travel from here to here. So hang on. So from here to here, it would require this many calories. So let's imagine from here all the way to here would require 4 times 50 calories. Okay, so hang on. So from here to here, it would require this many calories for 4 milliliters. Okay, and then from here to all the way to here would require 4 times 50 this many calories. So if we want to know from here to here, then we can just get from here, well, we can just get this, take away this. The point I'm trying to make is that if you want to know the amount of energy needed from here to here, then you can just get this, take away this. Okay, even if you start from, let's say 10 degrees Celsius, if you work out the amount of energy needed to get from here to here, and then from 10 degrees, then from here to here, you can just simply get this, take away this, even though you started at 10 degrees. It doesn't matter where you start. If you get this, take away. Well, if you want to know the amount of energy needed to raise the temperature from here to here, you can just simply get this, take away this, and then that will give you the gap in between here. Okay, it doesn't matter where you start. You can start at 0 degrees, you can start at 5 degrees. It doesn't matter. It's a bit like your integral here. It's a bit like your, let's say you got a function here. If you want to know the, let's say this point here is A and this point here is B. If you want to know this area here, you can just get from 0 to B, take away from 0 to A, and then that will give you whatever's in between. It doesn't matter where you start. Even if you start at 3, say, if you work out the area from 3 to B, then you can just take away from 3 to A. Then that will give you what's in between. Well, the point I'm trying to make here is that if you want to work out the energy needed to raise from 23 to 50, you can just get this, take away this. Okay, I will continue in the next video.